Hello and welcome back to Leilani Electronics. Before we get into it, go to the website, leilaniElectronics.com, print out the schematics. I'm going to have some part lists up on there. Um, like and subscribe to the channel so you can continue to get some updates and some more awesome videos. This circuit right here is just a basic traffic light that I built a while back. Finally got around to making it using your basic CMOS chips. The original one was just microcontrolled, just one chip, 3 transistors, and 3 high brightness LEDs. So what I started doing was trying to make the projects that I do, some of them not require a microchip for those who don't program. So this one uses CMOS chips to do the same thing one microchip could do. All right, here's a circuit in front of you. I got 10 millimeter LEDs and 20 millimeter LEDs. I needed a lens to try to increase the brightness of the bulbs. So what I had to do was went to the grocery store, bought 10 jars of baby food in different sizes, and I found out that the smaller jars work well with this circuit. I'm going to show you that. It's right here next to this one. But while I was building this, testing it out, I had the LEDs, so I had to try to simulate traffic light housing. So I just got some cardboard, as you can see, and put them over the LEDs to try to keep the light, focused so like you could see it and not spread out. So there they are. Just yellow, red. That 20 millimeter one down the bottom blew out, but you can see how the 10 millimeters are pretty bright. And my original one just did this red, yellow, green. And if you notice, the yellow, just like a regular traffic light, the yellow doesn't stay on as long as the red and the green. So that's why that one's on a short period of time. So we can speed it up, or you can slow it down. Now the next part I did was make your flashers. Like when you drive around at 2 a.m. in the morning, sometimes they're flashing red or yellow. So I got a switch here. And then this switch goes between yellow and red. And I'm getting to the schematic in a second, but it's pretty slick. Okay. Now all this is on a breadboard, so I had to solder up an identical circuit right over here for the bigger board. And there it is. There's a lot of wires behind there. I'm not going to show you all that. It's kind of a rat's nest, but I just soldered it up. Used to design my own board, so I had to dig deep into the parts pile to get some sockets, wires, and in my bin of CMOS chips. They run at 9 volts. So I'm going to turn the bigger one on, and it operates the same as the breadboard, but I just soldered it on this so you can get the effect. Now the other board is behind this board right here. This is just a piece of baseboard that I had from some remodeling. So I drilled 3 holes in it, stuffed the baby jars into the holes, and each LED is on a circuit board with its driver circuit. Then it ties over to the main board down there. So I'm gonna turn it on and turn the light off, so you can get a better view of how it looks at night. So we're gonna turn it on. And same as the smaller circuit, I have a potentiometer here. We can speed it up. And again, the yellow stays on a little bit less time than the red and the green because it's just, this is how the traffic lights are, or you can slow it down. Then I have the switch here to go to my flashers. And then the other switch, I'm trying to see in the dark. Oh, that turned it off. Wrong one. Well, I can't see in the dark, but you get it. It's flashing. So I'll switch this back. Here we go. It's pretty neat. It was a fun project to build. So once I make this permanent, I'm going to draw up my own board, drill it onto a piece of plywood, and then permanently mount it to this piece of baseboard. And it'll all be nice and neat. Okay, let me turn my light back on. And now we'll get into the schematic. Let's get a, there we go, so we can see that. Okay, here's the original one. See, it just uses a 555. It goes into a 4017, which is a 1 of 10 counter. Or you can use the 4514 as a 1 of 16 counter, but that would be a bit much. But you could use that if you have one laying around. Just substitute it for this one. Okay, I'm not going to explain this one because I'm explaining it on the second one, which is identical to this one except the flashing circuit. Okay, there's your 555, which generates your clock pulse, into your 4017, which is going to count 1 through 10. Okay, these are OR gates. So OR gate is when any input is high, the output is high. So what I did was tie the first 4 outputs to the green, the second 2 outputs to the yellow, and the last 4 to the red. So that's how you get your yellow to be shorter. Okay, pretty simple. Then the outputs of the OR gates drives a transistor, which is tied to your LED, which I'm going to use. These LEDs are rated at 20 to 30 milliamps. I wanted something more brighter, so I got to find some. I want them to be bright so you can see it more in the daytime. So this is your transistor. When the output goes high, it turns on the transistor and it, turns the LED on. So these transistors can handle up to I think 200 milliamps. The 2N3904. You see how each output is connected to a transistor to power that LED, because these CMOS chips, you don't want to try to run LED straight from the chip. Most of the CMOS chips can handle maybe 10 to 30, but just to be safe, when I do substitute these for the high brightness, I need to have a transistor to get up to 40, 60, 80 milliamps. Okay. That part is just for your, standard traffic light, red, yellow, green. So what I added on from the original one was a flash. See, here's a switch, normal and flash. Now the 4017, it has to be, the enable and reset have to be low for it to count. So that's why the switch, when you put it down, it's ground, so it'll count. And, it'll go 0 all the way to 9. It'll just keep recycling. So to disable the count, you just tie that input and reset to high. And then when you do that, it stops counting. But here's the tricky part that I had to figure out, was that when you disable it, it stops counting, but the output 0 goes high. It just stays at 1. So what I had to do was I put an AND gate on the output before it goes to the OR gate. Let me explain how that works. When this goes high, Now this inverter sees a high on input, then the output goes low. And once this AND gate, if any input is low, it's always going to be low. So if this input is high, you got a high low, this will be low. So now your green is off. That's what you want. You want all these off when you're ready to disable it. Okay, and then this clock post also gets tied into a JK flip-flop, which is the 4017. So what I did also is on the yellow and the red only, I took one of the OR inputs into to an AND gate. So we'll go back to here. When this is high, you're disabling the 4017. Now you're putting a high on the AND gate, so they're ready. So now when your clock pulse comes into the JK flip-flop, which the JK flip-flop is, every time it sees a clock pulse, it's going to toggle the Q and the not Q. So Q will be high, not Q will be low. When it sees a clock pulse, it'll flop. Now Q is low and not Q is high. And it'll just keep doing that every clock pulse. So I took the output of the JK into the second switch, which I showed you. Now this clock pulse is feeding this AND gate. Remember, this one is high. So now when this high into the AND gate, this goes high. And remember, this is the OR gate. So anytime they see a high, it's going to give you high output. So it'll flash yellow and it'll keep doing that forever and ever. And then if you want to toggle it red, now your clock pulse goes down to the AND gate for the red. And now it toggles that. And that's where I get you can toggle between your red flasher or your yellow flasher. Now I got pull downs on here because you never want to leave an input just floating on CMOS or TTL. So that's how I did that. Here's your unused gates. You want to ground them. You don't want to leave them floating. So again, you go back when you want to turn your flashers off, normal traffic. You toggle this back to low. Now this is enabled. It'll start counting, and once this is low, it'll put a low on these AND gates, so it'll always be low and won't interfere and start flashing. And when this is low, this 4049 is an inverter. So when this is low, this is high. So now this AND gate right here is high, waiting for him to go high. So when the low goes high, now he's takes a high into the OR gate, turns on the green. Another quick thing is I use the inverters on the output of the 555 because when you look at the 555, the outputs stay high and then go low. It doesn't idle low, and then when you need a clock pulse, it goes high. The 555 stays high, and then it pulses low, high, and then it stays. The duty cycle, I think, is like 90%, 80 or 90%. So it's going to be high, then low, then low. So what we need for the 4017 and the JK, the 4027, you need low to high clock pulses. So what these inverters do is now when the 555 is high, it'll be low. Then when it goes low, it'll toggle high. So now you have your clock pulses high to low, high to low, high to low. And this is your speed, which we adjusted if you want your light to be faster or slower. So that's pretty much it. Go to the website, print this out, get out your, order you some parts, build this. It's a nice circuit. I'm gonna do another video on how I drilled my holes for the jars, and show you how I mounted them on the back. But right now it's like a lot of wires back there because, again, when I do the circuit board, it's going to probably be like maybe 3 by 3 inches or whatever. So it's going to be fairly small. Same with the board right there, as you can see. Let's get a better look. See, this one's still flashing. Let me turn the light out once again and give you one more example. So we'll go back to the flash, and then we will there goes your red. Now, actually, these 10 millimeters seem a little bit brighter than the 20. So, but it's giving me the effect that I wanted. So everything worked out fine. Hope you liked it. Go to Leilani Electronics, print this out, build one, and have fun. Again, www.leilaniElectronics.com. Like and subscribe. Tell me what you think.